Hello guys, my name is Liad Hossain. This is my first video. I have decided to cover data structure and algorithms as much as I can. This is the first video in data structure series. In this lecture, I will complete linked list. So without any delay, let's get started. First of all, what is linked list? A linked list is a linear data structure in which the elements are not stored at contiguous memory locations. So what it means, contiguous memory locations. So if you assume these as memory locations, suppose these are the memory locations. So these are the contiguous memory locations one by one. These memory locations is after this and this after this. So linked list are not stored at contiguous memory locations actually. If you create an array, they are stored at contiguous memory locations. If you create an array of size 4, suppose, if the first value or first member of the array start at this position, then the next or the second element will be at this memory location. Then the third will be in this. Then in this way, they will be stored, right? But in linked list, this is not happened actually. When we create a linked list, we actually create node, right? We create firstly this node, then this node, then this node, right? Suppose when we create this node is created in this memory location. So after that, when we will create node B, it can be created at any locations. Suppose this is created in these locations. Then what we do? We actually linked these locations with these locations, right? Then we again create this node. This node can be created in anywhere, suppose in these locations. Then we link this memory with this memory, right? So in this way linked list is created. So here is head is pointed to the first elements or first node. A node actually contains two types of data. First is data field and another is a next pointer which contains address of another node. The next pointer of the last node contains null, right? Okay. So in simple words, we can say that a linked list contains of nodes where each node contains a data field and a reference linked to the next node in the list, right? Okay, let's move. Then why linked list? We can use array as a linear data structure. Why we need linked list actually? Arrays can be used to store linear data of similar types, right? But arrays have the following limitations. Arrays have some limitations. Let's see, the first limitation is the size of the arrays is fixed, right? If we create an array of size 10, then the array will not store more than 10 values, right? But we can create linked list as more values as we want, right? So the linked list, the size of the linked list is not fixed, right? So inserting a new element in an array of elements is expensive. So why it is expensive? Let's see. Suppose this is an array. Suppose this is an array. Suppose this is 2, this is 5, this is 8, this is 10, right? Then if we want to insert a new element at the middle of 5 and 8, suppose we want to insert 3 in this position, then what we have to do? We have to shift 8 and 10 to the right? We have to shift 10 to the right one block, and again we have to shift 8 on block to the right, then we can insert 3 in this position, right? So if we have n elements from this position to the right, then we have to shift n elements, right? So this needs big of n time complexity actually, right? But linked list don't need this much time actually. So if we have, suppose, some node, if we have some node and we want to insert a node in the middle of these two nodes, suppose these nodes are actually linked with this way, right? Then if we want to insert these elements in the middle of this and this, then what we have to do, we have to link this node with this node first, then this link will be cancel out, then we have to link this node with this node, right? We have not shift this to the right? We have not shifted these values or this node. So this is a constant time operation, right? But there is a problem. What is the problem? So that we have to traverse the linked list to find this node actually, that the node after which we have to insert these elements. So we have to traverse this, so this needs time actually. But if we have the pointer of the position of these nodes, then we don't need to traverse this. We can actually do the operation in constant time. This don't need expensive time as an array. So then advantages over arrays. Firstly, dynamic size. We have discussed it that the size of the array is fixed, but the size of the linked list is not fixed. Then ease of insertion and deletion. We have also discussed it. In the way we insert the element, in the reverse way we delete the element from linked list also. So this is also a constant time operation. So then drawbacks, random access is not allowed. So in array we can directly access a value or a node by indexing, right? We can access the second index of the array or second value of the array, right, by this, but we can't do this in linked list, right? Why? Because simple, array is stored at contiguous memory locations, that's why we can actually directly access this. But in linked list the nodes are not stored at contiguous memory locations, they can be stored at anywhere. So to reach the node we have to traverse, right? So random access is not allowed in linked list. Then extra memory space for a pointer is required with each element of the list. In linked list we have a data field, right? We have a data field, this is a data field, and this is a pointer, right? We need a pointer to link with another node, this is the next pointer. So this needs an extra memory space, right? So that's why linked list needs more memory. So this is not cache friendly, right? Okay. Then types of linked list, there are generally three types of linked list: singly linked list, doubly linked list, and circular linked list. We will describe them briefly. First, singly linked list. So what is singly linked list? We have seen it. Linked list is a simple linked list actually. Singly linked lists contain nodes which have a data field as well as next field, which points to the next node in line of nodes. So we have seen it that singly linked list in this way, it has some nodes. These nodes are linked with each other one by one. in this way. Last one is null, and this is pointed to be head, right? So it's a simple linked list, right? Okay. Then doubly linked list. A doubly linked list contains an extra pointer, typically called previous pointer, together with next pointer data which are there in single linked list. So in single linked list, we have only a next pointer to linked with the next node, right? But in doubly linked list, we have next pointer and also a previous pointer to link with the previous node, right? In this way, this is the first node is pointed to be head. The previous pointer of the first node is actually null, so the next pointer is pointed to the next node, and the previous pointer of this node is pointed to the previous node, right? In this way, double linked list is created. The next pointer of the last node is actually null. So this is the way a double linked list is created. So this is previous pointer, this is data field, and this is the next pointer. Advantages and disadvantages of double linked list over single linked list. So a double linked list can be traversed in both forward and backward direction. So this is a advantage. When we need to traverse in forward direction, we can traverse in forward direction. When we need to traverse backward direction, we can traverse in backward direction also. What we don't do in single linked list, right? So then disadvantages over single linked list. Every node of double linked list require extra space for an previous pointer, right? In single linked list, we have a data field and a next pointer, but in double linked list, we have also a previous pointer, so we need extra space in that case. Second, all operations requires an extra pointer previous to be maintained, right? If we insert an element, we have to maintain next pointer, and we have to also maintain the previous pointer. So this is an extra operation. So then circular linked list. Circular linked list is a linked list where all nodes are connected to form a circle. So in this way, actually, it is pointed to first node, then first node pointed to the next node, then second node pointed to the third node, then if this is the last node, then last node pointed to the first node again. So in this way, a circle is created, right? So this is a circular linked list. So in this linked list, there is no null at the end. In single linked list, we have seen that there is a null pointer in the end, at the end, and in double linked list, there is two null pointer, right? The next pointer of the last node is null, and the previous pointer of the first node is also null in double linked list. But in circular linked list, there is no null pointer. The next pointer of the last node is pointed to the first node again. So we can make circular linked list as a singly circular linked list or as a doubly circular linked list. It is a single circular linked list. You can see that there is only a data field and next pointer. So if we want to make doubly circular linked list, we can also make it. Then we will need a previous pointer also, and then actually it will create two circle actually. One is forward circle and the other is backward circle, right? So advantages: any node can be a starting point, right? You can start at this point, you can start from this point, you can start from any node. If you start from this node, you can traverse the whole linked list by this. You will go to A from C, then B from A, then again C from B, then you will actually end the loop. So circular lists are helpful in applications to repeatedly go around the list. If we need to do this kind of work, a circular kind of work like this, we have to do some work after this, then we have to another some work after this, then we have to the first work again, then this work again. Then in this case, we need circular lists, right? That was all for today. In next some videos we will see the creation, insertion, deletion, all these operations for single linked list, doubly linked list and circular linked list. We will see how to code them. So till then, keep enjoying and thank you.